Here at our Classtime Chapter 2, it's a little more math intensive here. We want to talk about the law of multiple proportions, and then I want to do a number of dimensional analysis problems. We're taking them to a new level in Chem 2, however, it's the same general practice you learned in Chem 1. Okay, so for the first one, we're taking a sample of methane, CH4, and they tell us the masses of the carbon and hydrogen in each of them. And then they say they have another sample, and they're trying to figure out if it is a relation to the CH4. Does it have the same proportion of carbon and hydrogen? So for the methane first, we determine the amount of carbon in the entire sample. So there are 46.21 grams of carbon in the entire total, which is the carbon plus the hydrogen, and that comes out to a ratio of 0.923. And then we do the same for the hydrogen, and we find a ratio of 0.0774. And then we take that same analysis for the other sample. They tell us that there were 51.25 grams of carbon divided by the total, and that gives us 0.2923 again. And the hydrogen has a similar ratio to methane, which is 0.0774. So we can see that these are in the same proportions. Okay. Now we have a compound that contains only carbon and hydrogen, and it has a carbon and hydrogen ratio of 11.89. And it says what carbon to hydrogen ratio is possible for another compound made only of carbon and hydrogen. So remember, the law of mass proportion says that you can only have these in whole number ratios. So what we're looking for here is a whole number ratio that is a multiplier. So when I divide the 11.89 by 2.50, it must give me a whole number, and it doesn't. I look at answer B, and it gives me 2.99, which statistically is the same as 3, and so that is a whole number ratio. So what that's saying is 3.972 multiplied by 3 will give us 11.89. That is a whole number ratio. All right, ladies and gentlemen, moving on to number 3, that is a the first part is a very simple dimensional analysis problem. The second part I need you to look at and see what it's asking. It's saying if you figured out that there are 3.63 times 10 to the 23rd molecules of magnesium hydroxide, how many ions of hydroxide does that contain? Remember that 1 unit, 1 mole of magnesium hydroxide will break apart into 1 magnesium ion with a +2 charge and 2 hydroxide ions. So if we know the number of molecules of magnesium hydroxide, we can easily figure out the number of moles of magnesium hydroxide, and we use the relationship that 1 mole of magnesium hydroxide contains 2 moles of hydroxide ions to get our answer. And I will go through and show you the answers to the rest of these problems, and you should be good to go from now on with dimensional analysis.